Okay, welcome back to today's lessons, and we start as always with the quiz. These quizzes are so good for, if you remember at the start of the year I showed you a video how if you want to remember things you have to revisit them. A week later, 2 weeks later, a month later, 3 months later. That's the point of these quizzes. So if you're still doing them, you're going to see huge benefits when it comes to the end of the year because you're forcing yourself to revisit some of these ideas now that we've left behind a couple of weeks ago. So well done. As I said in the last two quizzes, there are some questions I've thrown in there with two correct answers. If you want to maximize your answers for those, go for the middle. Okay, let's get started. Pen and paper ready. So which of these three situations has the largest final speed? So pause and I'll let you read and work your way through that as I move now on to question 2. A boy throws a ball upwards. So just looking at the flight of the ball on the way up, which of these three motion maps is correct? So pause, so you've got a bit of time to think about that one. And I'll move on to question 3. Which of these three situations has the greatest acceleration? So you have to do a little calculation here, so just pause, work through that, and I'll move on to question 4. I want you to draw a force diagram for the cart. So the hint is just draw your system box, choose your system to be just that cart. Okay, and pause to work your way through that, and I'll go through answer number 1 now. So answer number 1 was 2 correct answers. Something starts at rest, it increases its speed by 3 meters a second for every second. Then after 1 second, its speed's going to be 3 meters a second. It increases that again, so after 2 seconds, its speed's going to be 6 meters a second. And it keeps increasing that by 3 meters a second every second for 20 seconds, so its final speed is 60 meters a second. A ball's dropped and accelerates at 10 meters a second for every second for 6 seconds. So after 1 second, it's 10 meters a second. After 2 seconds, it's 20 meters a second. After 3, it's 30, blah, 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 blah. After 6, it's 60 meters per second. So same answers. This one starts at 70 meters a second and it slows down at 10 meters a second for 2 seconds. So after 1 second, it's down to 60. After 2 seconds, it's down to 50 meters a second. That's why that is not the correct answer. Number 2 is a boy throws a ball upwards. So it starts with a high initial velocity and its velocity gets smaller. That's why this one's wrong, because the velocity gets bigger. And because its velocity is getting smaller, the acceleration should point in the opposite direction. This acceleration points in the same direction. So that's why that's incorrect. And that's why this one is correct. Which has the greatest acceleration? So acceleration is force over mass, or net force over mass. This has a net force of 5 newtons and a mass of 5 kgs, and so that's 1 meter a second squared. This has a net force of 6 newtons and a mass of 3 kgs and 2 meters a second squared. And this one had 1 newton over 1 kg, and you're going to see that's equal to 1 as well. And number 4, draw a force diagram for the cart. This is why these system boxes are so powerful. You can say, aha, that's all I have to worry about. And the rest I don't need to worry about at all. So force of gravity on cart by Earth. We have the normal force, which is probably this, well, it is the same size because it's not accelerating up or downwards. F normal on cart by, is that a table? I don't know. We'll assume it is. Table. And what else is, anything else touching it through the system? Yeah, this rope is. So you can say F tension on cart by rope. And you could have said by mass 2 or by string, as long as it's generally descriptive of what's happening. So 3 marks there. Okay, I'll see you in the rest of the lesson.